Hi, do you know this famous guy? Yeah, Albert Einstein. But how many of you guys understand about what he did? Don't worry, I'll explain it for you. So, the strange begins when we realize the speed of light is a universal constant. If you place a light source in front of the moving train, the light speed will not be faster. It's still the same. That inspired Einstein to introduce his special theory of relativity. He imagined, if someone turned on a flashlight inside a train that moved at the speed of light, the flashlight inside the train will move like this. Nothing special. But what if someone on the ground observed the light and this moving train? In her view, the light moved like this, since the speed of light is constant. Look, if we measure two lights travel different distances with the same speed, obviously, the time takes by them will be different. It means time for the man inside the train was running normally, while from the woman's perspective, the time for the man should be slower. But how can one event of moving light have two different timing results? That's why Einstein thinks we should consider time as our fourth dimension, because there is a hidden connection between three-dimension space and time. For Einstein, the event of the falling apple, for example, are just a slice of three-dimension phenomenon which walk toward time in our fourth dimension of space-time. However, we can't see this fourth dimension of space-time. What we only see is the lower dimension of this falling apple, that is three-dimension events. But why in space-time apple looks like fall to the earth? The general theory of relativity. This theory said there must be a geometry or fabric in our universe that could be curved by the mass of the matter over time. So the apple and all objects affected by this curve of line and looks like fall to the earth. But the amazing is Einstein's general relativity says the apple doesn't fall at all, but the earth moves up against the curvature of space-time.
Oh my god, but what is the real evidence of this theory?
Gravitational time dilation. The light and any matter that travels near to the source of gravity experience time slower than the place that farther away from the source of gravity. Remember, the farther the distance that travel at the same speed, the slower the time. Two atomic clocks, super accurate clock in the world, have been placed at this different height. As a result, time on the ground ticks slower than on the mountain. So general relativity proved. In conclusion, Einstein's special relativity tells us that time is relative depend on the observer, and the general relativity tells us that space and time should work together as our four-dimension fabric that could be curved by the mass of the matter, so affect our object as we know as gravity. So, do you know this theory better, huh? I hope so.